Section 7.5, different ways to express probability. Probability is mostly about the probability that something is going to take place. So when you're conducting an experiment and the outcomes are equally likely to happen, the probability of a certain event happening is the number of outcomes favorable to that event and the number of possible outcomes. Well, it sounds kind of wordy, but the way of thinking about it is if you were to do something, and any possible way that it could end up or happen or finish would be your possible outcomes. If we were to look here at this coin being flipped, there are only two possible outcomes. It's either going to be a heads or it's going to be a tails. So I know that in this case, I've only got two possible outcomes. It's either going to be a heads or a tails. So whatever I get is going to be one out of two. If I were to say, start it and say, what are the possibilities of me getting a tails? Well, I flip it and, oh, there you go, I got a tails. So in this case, there is one possible favorable outcome. That favorable outcome in this case was to get a tails. Out of two possible outcomes, the only thing that can happen when you flip a coin is that you get a heads or you get a tails. Now, if I were to say, what's the probability of me getting a heads when I flip a coin? Again, there's only two possible outcomes, a head or a tails. And what's the probability of getting a heads? Well, there's two possible outcomes, and one of them is a head, so one out of two. Now, of course, if I were to flip a coin, if I started and I flipped it once, I flipped it again, I flipped it again, I flipped it again, I got three tails and one heads, but that doesn't mean that my probability of getting a tails is 3 out of 4. My probability of hitting a heads or a tails is still 1 out of 2. One outcome out of two possibilities. To look at that a little differently, let's look at a dice. Now a dice has, in this case, a dice has 6 faces on it, which means there are 6 numbers that could possibly come up when I have a dice. I could roll a 1, a 2, a 3, a 4, a 5, or a 6. So, if I roll the dice, there you go, I got a 6. What's my probability of getting a 6? Well, it's 1 out of 6. My number of possible outcomes with a dice, my number of possible outcomes, like here, is 6. And the number of outcomes favorable to that event basically means what are your chances of getting something. My chances of getting a 6 are 1 out of 6. My chances of getting a 5 are 1 out of 6. My chances of getting a 3 are 1 out of 6, if you're seeing the pattern here. Now I could roll a dice and I could get 6 and I could hit 6 and I could hit 6 3 times in a row, but that does not mean that my probability of hitting a 6 is 3 out of 6. My probability of hitting it is still 1 out of 6. Every time I roll the dice, I have a new chance out of 6 to hit something. So let's take a look at that. Probability can be written four different ways. One of them is simply in words. So what is the probability that I could roll a 4 on this dice? It's the same idea. The probability of hitting that would be there is a 1 in 6 chance of hitting a 4. Okay? Now that's just in words. That's literally writing that out in words. A 1 in 6 chance of hitting a 4. What ratio would that be? Well, again, the ratio is written fairly close to the same. 1 in 6. I have a 1 to 6 chance of hitting a 4. What is the fraction? Again, 1 in 6. I have a 1 in 6 chance of hitting a 4. And what's my percentage for that? Well, the percentage of that, we've done this in another unit, but the percentage of that is you divide 1 by 6, and that gives you a 17, approximately rounded, approximately a 17% chance of hitting a 4. So this is the same probability written 4 different ways. In words, as a ratio, as a fraction, and as a percentage. Let's look at that again in a word problem. So Sam buys a box of different flavors of food for his cat. In a box, there are 14 packets of fish flavor, 2 of chicken, 4 of beef. Sam takes a packet out of the box without looking. So he just reaches his hand in, doesn't look. What's the probability that he picks a packet of chicken-flavored food? Well, we know that there are 20 in total, and there are 2 for chicken flavor. So he has a 2 in 20 chance of pulling chicken flavor. Okay, he has a 2 in 20 chance of pulling that. But, of course, as we went through with fractions, we realized that 2 and 20 can be made smaller, and I'll show you what I mean. If we come down and do a ratio, it again is 2 to 20. The fraction, again, is 2 over 20. But when we get to a fraction, as we've done before, you can realize that 2 and 20 can be made smaller. So actually, he has a 1 in 10 chance of pulling chicken flavor. And that his ratio is 1 to 10 in pulling that. And that he has a 1 in 10 fraction of pulling the chicken. And then if we look at his percentage as well, of the chance of that happening, or the probability, pardon me, of that happening, we take the top, the numerator, and divide it by the bottom, the denominator. He has a 10% chance. He has a 10% chance of that happening. So, 20 packages in the box, 14 are fish, 2 are chicken, 4 are beef. He reaches in without looking. He grabs a package. What is the chance that it's chicken? Well, a 1 in 10 chance, a 1 to 10 ratio, a 1 over 10 for a fraction, 1/10 of a chance, a 1/10 of the time. The probability is it would be chicken, and there's a 10% chance or 10% probability he would pull out chicken. But there are a couple of times where you don't even need to think about it. When all the outcomes are favorable to an event, then the fraction, or the number of outcomes favorable to the event over the number of possibilities, when the top, or the numerator, is equal to the bottom, the denominator, the probability is 100%. So in the case of Sam and his cat food, he had 20 packages. What's the probability of him picking a package of cat food? Well, all 20 packages are cat food, so when he reaches in and pulls out a package, it has to be cat food. There's no dog food, there's no bird food, it's all cat food. So 20 packages of cat food, what's his chance of pulling one package of cat food? 20 over 20. 20 divided by 20 is 1, or 100%. This is called a certain event. Is Sam going to pull a thing of cat food out? Yes, he's going to pull a package of cat food out. It's a certain event. Now, when none of the outcomes are favorable to an event, then the fraction has a numerator equal to 0, and the probability is 0. For example, what's the probability of picking a package of pork-flavored cat food? Well, the only kinds in there were seafood, chicken, and beef. There is no pork. So it's a 0 out of 20 chance, and they call that an impossible event. They call that an impossible event. Now, other than certain and impossible events, so when it's a certainty or 100% that it's going to happen, or it's an impossible event and there's 0% chance, all of the probabilities lie between 0 and 1. So if you're to look back, 10% is between 0 and 1. 17% is between 0 and 1. All probabilities other than certain events and impossible events fall between those two numbers. So, as you practice, using a calculator if you need to, write the probability of each event as many different ways as you can. And the 4 ways we talked about are with words, with a ratio, with a fraction, or with a percent. Here are the 4 events. You roll a 3 or 5 on a die or a dice labeled 1 to 6. What's the probability that January immediately follows June? What's the probability to pick an orange out of a basket that has 2 oranges, 6 apples, and 8 peaches? And what is the probability that the sun will set tomorrow? Are any of these events certain or impossible events? And tell me which ones. So there's your question for homework. Number 1, A, B, C, and D, and then this extra piece at the bottom that I added.